Hello, this is a program to calculate the factorial of a number, and I will be using recursion within a function. And recursion is a function that calls itself. So let's get started here. So the first thing to do inside of a main is to declare variables. And I just need one variable here. So in FAC, I do not need to pre-assign it because I'm going to ask the user to input the value. And it's always nice to print out what's been input. So cout, you entered. Okay, now it's the point where I would like to write the function. So this is a non-void type, so I must return to this function. And I need to also give the type for the argument. And now I'll do my function call, and I do not need the type here for the call, and I'd like to use cout it's a convenient way to obtain the output from a function call. And let me do an inline here too. Okay, now let me do the last part of functions, and that is the third. Actually, writing the function is the third part of functions. Note you do not have a semicolon here. Okay, with recursion, you have to have a base case, and that is to end the recursion to stop the recursion from occurring. So I'll use the selection statement here. If fact equals 1, return a 0. When you return a 0, you essentially end that function. And now let me actually write the recursive portion. Okay, so I'm just going to simply return FAC times the function itself. And you notice that with factorial, you need to multiply the original number times all the numbers decreasing from there. So let me remove that. And I need to subtract 1, right? Because if I was doing a factorial of 3, I would do 3 times 2 times 1. Okay. Let me close that. Return. Alright, looks like I may have too many. Here I do need a semicolon. So let's run this. Okay, let me pause here. I need to do some improvement here. I'm going to remove this. It's a little distracting to have that end line right there. And this, for the base case, I realized that actually with factorial you multiply, for example, 3 times 2 times 1. So I need to end this one. This is a 1. And I need to return a 1 here instead of returning a 0. And let's take a look at this. So I'm going to do a 3 factorial. And you can see that this number right here is a 6, and that is correct. 3 times 2 times 1 is equal to 6. So let me improve the visual aspects here. So see out the factorial is, let me do an end line here, and let's run it again. So let's do a 4 this time. So the factorial is 24. So you can see that it is recursively going through, and it is obtaining the factorial. 4 times 3 is 12, times 2 is 24. I'd like to improve this a bit. I'm going to say this. The factorial step is, and let's run it again. Oh, I would prefer to actually put in what this fact is, and let's run that. Let's do 5. Okay, 5, 4, 3, 2, and there would be a 1 in there, so it would be 5 times 4, which is 20, times 3, which is 60, times 2, which is 120. So that is the correct answer. Let me add in a do-while loop to have this repeat. So I need a char and repeat. And let me pre-assign that to no, n for no. And let's do a do-while. And let's ask the user if the user wants to end or not. If I need to read that in, and I would like to close the do with a while. So while repeat is equivalent to a lowercase y, or repeat is equivalent to an uppercase y. And a do-while is the few cases where you do need a semicolon after a while. Let's do a 4 again. 4 times 3 is 12, times 2 is 24. Repeat, yes. Let's do a 5. That's 120. Very good. No. End. Thank you.